take it away. So yeah, go ahead, Dennis.
All right, let me get my screen share going. I'll just, yeah, do the whole desktop, why not? So one of my kids wanted to make, as a present for a friend, one of these Gambit coins from the game Destiny 2. And I know nothing about Destiny 2 nor Gambit coins, but showed me some pictures online. There's apparently a real one that was at PAX West. I think it's made out of vinyl, but it's selling for like $150. And there's some resin cast ones that you can buy, and even some 3D printed ones. But we wanted to take this on as a 3D milling challenge, and because I want to do some coin-like objects in the future, so I thought this would be a good learning project. So we scoured around and found an STL file on the internet, and it was just the top half of it, so we kind of mirrored it and flipped it around to be both sides, and then created some tool paths. This, actually, that's the second try at it. The first try at it, I had a 1/4 inch facing pass, and then a 1/4 inch adaptive, and then progressively smaller bits, 1/8 inch adaptive, 16th down to 32nd adaptive, and 64th adaptive. This was actually the second try. The first try tried using a 1/32 ball end right after the, I think, 1/32 adaptive, and that ended up breaking a bit. So it was my first broken bit on a project. Then we revised it to be just flat end mill adaptive paths all the way down. And I originally thought I'd be able to go all the way to 1/64th, but as soon as that one started moving, it snapped right away. So that was my second broken bit on this project. But ultimately, just by going down to 1/32 and doing a parallel path, we were able to get a pretty good surface finish acceptable for this project. So this is after the 1/4 inch facing and then adaptive path. And then this was after the 8th and 16th adaptive, and now it's doing a 32nd parallel pass. And that's, then I ran that ball end 32, and that's where it broke right there. There's these holes that back in the original drawing, you could see that these actually passed through. And the adaptive path hadn't even touched these. And then the parallel path came along and just buried the end mill right into that aluminum and snapped off. So that was a learning experience. So kind of redid things and was a little bit more conservative on the paths, and ultimately came up with this version. The other half of this challenge was the fact that it was two-sided. And so originally I thought I would mill the whole thing and then somehow flip over just the middle part. But then it occurred to me, if I don't mill all the way through, I can leave this little webbing here. And the original thought was to make that about 1/2 millimeter. In the end, it ended up being about 0.2 millimeter. Not quite sure where I did my math wrong. But the really nice part about it is that would allow me to just flex it back and forth and even peel it off by hand. Unfortunately, this picture's of the back, where I also actually made a mistake on a tool path, and it ended up taking a little bit of material off it should not have. The challenge, and Chris and I talked about this a little bit ahead of time, because he said, well, how are you going to index this? I ended up using this left corner here for the front pass, and then flipping that 180 degrees, and then indexing off now the right corner, which is that same bit, for the back pass. And in the end, it actually turned out better than I thought it was going to in terms of alignment. And so I was able to file off a little bit of what effectively is flash, and have a pretty good piece in the end. The surface finish coming off the machine was kind of from this parallel path going back and forth, so it was a little bit rough. So I hit it with a wire brush on the Dremel, and then bought some polishing compound that said it was supposed to work on aluminum, and kind of used the, I don't know what those are, cloth wheels or whatever on the Dremel. The problem with this is there's a lot of recesses that those couldn't quite get to. So it's a little inconsistent in the polishing. And so I really want to explore and learn a little bit more about other surface finish techniques. I think this one was after the wire wheel, and then this one is after the polishing. The light's not quite as good though. So I want to explore bead blasting, and if people have any thoughts on that, I'd like to hear them. And then I also noticed when I was at Harbor Freight, they have this vibratory tumbler that you can put some media in and let it run for a couple hours. That also produces some kind of a surface finish, but that's quite a bit pricier than a real simple bead blasting setup, if you don't get the enclosure for the bead blaster at least. But that was the two-sided project. It didn't make holes all the way through, but it made holes in most of the appropriate places, and the child was happy with the result. So any questions on that project?
Try again.
I've got 10 questions.
Okay.
One of them is, did you try drilling out those holes instead of milling them out?
That was the original thought, is that I was going to leave them as part of this webbing here and then drill them out. But then at the last minute, I realized, well, I could actually make a machine path that is a separate pass and just pokes through those with the end mill,
Okay.
the same one that it used for everything else. And I'm really glad I did that, because this picture is at least 2x normal size. Like I'd have to, I don't know if this lets me shrink down. I think it only lets me go bigger. But this thing is only about a little under 2 inches big. So it would be a tiny little drill that would have to go through there. So I'm kind of glad I milled those.
So, and you were talking about surface finishes, those adaptive paths aren't necessarily set up for surface finishes. But you tried playing around with like the horizontal stuff in Fusion and the flats and whatnot?
Yeah, that's what the parallel pass was all about. Like if I switch over to Fusion, yeah, like you said, the adaptive paths are all about hogging out material. But then the pass, it uses the 1/32 and it runs this parallel path. And I told it also, when there's steep contours, it puts them closer together. So like where there isn't one, it's a little further apart, and where there is one, apparently here, it puts them closer together. And I also left a little bit of material on there. All of these adaptives, I use some of the, oh, what do they call it? I think they call it stock to leave.
Yeah, it's called leave behind.
Yeah. Here it is, stock to leave. I left 0.05 millimeters there. And that gives the parallel path something to bite into as it goes across. That was a recommendation I found online. But in the end, it's still this kind of almost scratchy like finish going back and forth.
So
The wire wheel cleans it up pretty good if you can get it into the crevices. But I've seen online some sandblasting or bead blasting results that makes a really nice matte aluminum finish. And I think that's a nice looking finish. And then other people do some polishing to get more of a mirror-like finish, but that seems like it's a magnitude more elbow grease going into that.
yeah.
Yeah, as far as your finishing goes, that the vibratory bowl tumbler is not what you're going to want, because it's going to knock down. The idea of a bowl tumbler is it's to remove the flashing on the edges of parts and the points. So it's going to knock down all of your points, but not touch anything else. So the media on there are these big triangles, and the big triangles kind of spit and spin around, and they hit the edges and the peaks, but not the valleys. You can put another media like walnut shells and abrasive, things like that. That acts a little bit differently, but it still does the same thing. It really hits the tops, and it's really aggressive on the edges and not anywhere else.
So if I want to get in here, a blaster is the way to go.
Yeah, so the sandblaster is what I put in chat before, and the sandblaster will definitely even everything out. The trouble with sandblast finish then is if it's handled, you'll remove the mat and you'll almost polish it where you touch it, which is sometimes a good effect over time, other times it's not. But aluminum gets this kind of like powdered gray sort of surface, and you got to clear coat it to protect it, to make it stay the way that you had it. But it's still a good, like sandblasting is a good first step before you polish it anyways, because it's like sanding it, but it gets in all the edges and the corners and stuff. But it'll have the same effect of rounding the corners and the peaks off. But it'd be a good step. You can do baking soda blasting. I've never tried baking soda blasting on aluminum. I don't imagine it do much, but you typically use that on really soft surfaces where you don't want to have a lot of damage. Like chrome, you can actually remove the rust from chrome without touching the chrome with baking soda.
Very cool.
Hey,
So it was
Dennis,
a fun learning project and they were happy with the results. So
nice. Do you know what kind of aluminum you have there?
6061.
Do you know what the hardness is?
No.
It's probably 6061-T6.
Well, yeah, because T6 is like a good millable. It's a harder aluminum than like a T4 or T3. And I find that when I got a T, like a harder than I break a lot more bits than the lower T numbers. And I'm only barely learning this stuff myself, but I've broken a handful of bits. So you pique my interest on that.
Yeah. I'm sizing the window to make it more like actual size, at least on my little 13-inch screen. And, then you can note, you don't notice the imperfections quite as much.
Yeah.
It's still about a foot tall here, so.
Yeah, I suppose. Yeah.
It looks awesome though.
Yeah, it's as wide as a quarter, basically. I should have put a quarter in for scale. I don't have a banana.
How long did it take to build it? Both sides.
What's that?
What was the building time for both sides combined?
It wasn't too bad. The facing down here is like 36 seconds. The adaptive is like a couple minutes. As the adaptives get narrower, they get longer. Like the longest one here is the 132nd adaptive is a half an hour. And then the parallel was an hour and 15 minutes. It turns out the Fusion estimates are really close. The Bantam software tries to do an estimate and it's like way off. Yeah, the only thing I didn't like about it is the free version of Fusion doesn't do rapids. Like the fastest the machine moves is your cutting speed. And so anytime it picks up and moves over and drops down, it's like annoyingly slow.
If only you knew a programmer who could maybe write a little script to find all the G0s and change them around.
I was actually thinking about doing that, but I wasn't sure if it was cheating or not,
That's never cheating. If you know how to do that, then I think Fusion's lost its audience anyways.
So how do you probe on that Bantam?
It's got a conductive probing system. And so you put in a 1/4-inch probing bit, and then it has an automatic one, which is great for big pieces of stock, but for thin stuff like this, it has a per axis way of doing that. And if you can't use any of those because maybe you have plastic instead of metal, you can just jog it and step it until, use the thin piece of paper type of approach.
Sure. Davey, do you know how do you get the personal Fusion licenses? I think you just ask for one and you can renew it forever.
Yeah, if you go to fusion.com and try to download the trial, it's like a casino. They keep steering you into a paid thing, but if you keep clicking on a student, I want a trial, then you'll eventually get a download link.
Chris, did you hear that?
Do you need a student email though for that to work?
No, you can just say you're an enthusiast or maker or whatever.
Yeah, you say you're a maker, an enthusiast, or a student, and all of them lead you down the same path. But like Davey said, you have to fight to stay on that track because they'll keep trying to say like, oh, only for a few dollars you can do X, Y, or Z.
Oh yeah. I think I've always managed to get like kind of railroaded into the like,
Yeah.
you've got a 30
how to
day.
get the personal license, and it is tricky because they keep trying to veer you off. Yep.
But as long as you make less than $100,000 a year.
It used to be that they changed it.
What did it?
Yeah, Sean was saying that it used to be 100K limit on income from it, but they changed the terms around. I forget,
And
it's
it
still
limits
generous, but
how many active projects you can have over here and stuff like that, but you can make them read only as long as you don't have, like I'm at 7 of 10. Whoops, my window's in the way. I'm at 7 of 10 active projects, but you can archive the other ones. So
half of me wishes Fusion would get super restrictive, and so would Onshape, and then let FreeCAD win. And once FreeCAD's got a good toolpath generator, it'll make stuff. It just doesn't do it quite as elegantly. But it's taken Fusion, a couple decades to get there too. So I don't know.
It's magic because like 20 years ago, this stuff was like you were saying $100,000, and the mills were not cheap either. So it's amazing you can run personal Fusion and use a 3D printer or a desktop mill. The power that you have is pretty cool. I got go listen only for a work meeting, but I look forward to seeing the other projects.
Thanks, Dennis.
Thank you.
All right, who wants to go next? Oh,
Go since mine's pretty small and quick.
what's that, Nick?
I can go on. Mine's pretty small and quick.
Yeah, go for it.
All right. We've got this 100-year-old antique lamp that was handed down in my wife's family for many years, and the other night the plug ejected itself with a flash and a bang. So I took it down to the shop, started taking it apart to see what was involved in rewiring it, and it's pretty standard stuff. But in the process, we found that somebody had broken this finial that goes on the top. And what happened was that this threaded piece here was part of this piece and broke off. So they just stuffed a pencil up inside there to hold this on. So all I'm going to do is turn this piece around, cut threads into here so I can thread it back into the finial again. It'll be just about 3/4 of an inch shorter, not noticeable, and then rewire everything as well. So I'm just starting this now, so I'll let you know how that goes. I guess I made a storm window this month too. That's not real exciting to show, but our old bathroom storm window rotted out, so I had to make a replacement. I did kind of a quick and dirty one for now, and I'll be doing one that's duplicating the original.
Is it traditional that you keep the asbestos lamp cord? Like, do you stuff it in a corner in the lamp then, or do you keep that inside of it?
I'll get a new old stock cord, probably cut something off of another appliance.
Yeah, they do make. You can buy on eBay. They make all kinds of old lamp. It's old light lamp cord. Obviously, it's all new stuff, but it looks just like the old stuff where it's all fiber wound and everything else.
Yeah. And thank you for sending me that link to Home Depot and to Menards. The sockets here are on this standoff, and apparently that's a pretty standard, or was a pretty standard item 100 years ago. I didn't find it except in an antique lamp specialty website. Chris was able to find it. Apparently it's on the shelf at the Home Depot, so I just go buy it there. Then the rest of it's just buying cord and switches to replace it. The antique lamp place, for pretty reasonable price, will sell you the whole kit of everything you need to do it too. For $70, I can probably get the pieces for a lot less.
How are you gonna spin that piece out? You coming over here for that?
I've got a friend, a machinist friend who lives over by Highway 30 and Thompson Drive, who's got a full machine shop in his basement. He helped me with restoring my drill press last month. So this is going to be an even easier project.
I know a guy will sell you like a $25,000 lathe for your basement. They'd be able to take that out, no problem.
No, we got a much smaller, $10,000.
10,000. Okay, you get a $10,000 lathe. We could probably fit in your basement too, if you want to.
You haven't seen my basement.
Oh, it's littler.
It certainly wouldn't fit down the stairs.
Oh, we could take it apart.
Yeah. Now, that's why I have Sector 67, so I don't have to have that stuff in the house. Although I will tell you, when I took the drill press out of the house, my girlfriend was watching. This was a big step in our relationship. When I moved in, I told her that I was committed to her, that this relationship was forever. But it really hit home when I moved a 200-pound drill press into the basement. Then, then she said, "Oh yeah, this is long term."
Well, we'll look forward to seeing the lamp back in its former glory with no pencil in the middle of it. That'll be good.
Yeah, I'll probably polish it up so it's a nice brass color again too.
If there's anything I've learned from Antiques Roadshow, don't touch that patina, Nick. Come on now.
We'll see. If this tube that broke, it may be that it'll break again, and we just have to get a new tube. And if I do that, then I might as well polish up the whole thing to match it.
Yeah. No,
But yeah, it's a pretty cool You can't really see it. It's a pretty cool patina, but it's pretty dark. It'd be nice to have bright brass finish.
You should
And
have
then
let,
clear coated, I guess, to keep it that way.
led Stoneface after Dennis asking, well, since you're running that little machine making finials, you want to duplicate this for me? I need like 12 more of them just to see
Yeah.
how much he'll wince before he says no.
Yeah, thanks.
All right, cool. Thanks, Nick. Scott, are you ready?
Yeah, I can go.
All right, take it away.
All right. So my name's Scott. I'm a member at Sector 67 with various interests, including metalworking. And this is I'm going to explain this device that I made in the machine shop at Sector 67. It's got you can see a dial on it there and this lever that when you move the lever, it moves the dial indicator and gives you a very precise measurement of what it turns out is what you're measuring is the distance between these two clamping points. You can clamp something in between there. So I've got a couple slides here. The device is called a bandsaw. It's a saw tension gauge. Let me pull up my slides here. And why do I need one of these things? So I teach a youth metalworking class for kids. I guess I'm what you would call a hacksaw aficionado. I grew up doing a lot of work with hacksaws. I enjoy teaching kids how to use hacksaws as a safe way to, make great, cool things out of metal. And I do a fair amount of metalworking on and using our band saws around Sector 67, including the wood shop and the metal shop both, which this device is good for measuring blade tension on those saws. So both bandsaw and hacksaw blades cut longer, but they cut better, longer and straighter when they're under high tension. But if you put them under too much tension, you can break them, or you can put too much tension on the saw frame and wreck the saw frame. So it's nice to be able to measure the tension on our saw blade so we can optimize blade tension in a more repeatable way when we're setting up saws around the space. And there are several ways to do this. So there's the German tensioning system Gutentight, if you're familiar with that. You can tune blades like a guitar. You can tension them and pluck them to get a sound, and some people do it by ear that way. There's actually an iPhone app that if you put in your blade cross section, it will measure the frequency of the blade pitch basically and tell you how much tension you have. And there are gauges that measure hydraulic pressure or spring movement on the blade as you tension it, but those only actually measure the stress on the machine, not the actual tension on the blade, which depends on, like, you can crank down the wheel to tension your bandsaw blade, and that'll put however much pressure on, but depending on how thick or thin your blade is, that's going to be more or less tension on the blade for the same amount of stress. So those approaches aren't necessarily as good as something that directly measures the blade tension. And so this device that I've made actually measures the blade stretch as you put the blade under tension. So the blades are steel. They do stretch as you put them under tension. It's not much stretch, but it can be measured mechanically. You can buy one of these for $300 to $500, which, of course, with many projects that we do around here, it would have been a bargain in retrospect if you count your time as anything other than free. But I wanted to practice my machining skills. This was a great project for doing that. So I copied a commercial device and made it myself. So here's a more close picture of it. You can see it's a standard 10,000th dial indicator that I put a different scale on for pounds per square inch, basically. The body's out of aluminum. Sorry, let me get to the next slide here. The main body and the pivot arm are aluminum. I've got steel and brass inserts for actually pinching the blade. It uses a 1/10,000th dial indicator. Typical dial indicators that you see would be a 1/1000th of an inch. And I use bearings for the pivot, even though that's completely unnecessary. So this pivot point here, there are bearings for that. And there's no real pressure on the thing. And it measures across 5 inches of blade. So from basically from this point to this point is about 5 inches. A little bit of the math here. There's a concept called Young's modulus, which is it basically measures how much of a given material stretches or compresses under a stress. And so knowing that our blades are a certain type of steel blade, and that we're measuring 5 inches of stretch. And my pivot point was even 1-to-1 ratio. I wanted to know how much 1/10,000th of an inch movement on my dial indicator represented in pounds per square inch. So there's the math there. It's 580 pounds per square inch per 1/10,000th of movement. Typical for carbon steel tooth blades is 15,000 to 25,000 PSI. So this gives a nice readable range. It's about half of one sweep of the dial is like about as high as we would want to go. I designed the part in Fusion 360, and I did the tool paths also in Fusion 360. That was a pleasure, honestly, relative to other ways in the past that I've done CNC tool paths. To actually manufacture the thing, the main machining was on the Tormach 1100 CNC mill. So really what I would call kind of the 2D milling parts of doing the main pockets and the profile were done with CNC on the Tormach mill. And then there are some additional features, slots in the sides, some threading and stuff like that I did. Some of the stuff I did on the manual mill with digital readout, and some of the stuff I did by hand. And so let me give you a demo of it here. So I have one of the things I got for Christmas, if you can see this, is despite being a bandsaw aficionado pretty much my whole life, there is something I didn't know existed, which are called high tension bandsaws. So normal bandsaw, you put the blade in and you turn a wing nut or something like that, and it tensions the blade. This, which I got for my younger son for Christmas, it's a high tension hacksaw. It says, so there it says, 50,000 PSI, more tension, more cuts. And if if cutting on if you're doing cutting on a hacksaw, more tension is better. So I'm going to demo this. So this will go to 50,000, which is higher than you ever want to take a bandsaw blade. But let me work out the logistics here. So I've got it loose right now. And the way this works is you tension it by turning this knob. It pulls this heel up. And so you get a significant mechanical advantage to tighten the blade. So just to understand what I'm doing in the demo here is I'm going to be turning this handle to increase tension on the blade. So I'm going to set the blade in between my two pivot points here. Hopefully that's coming over okay. I'm going to tighten this on. I can, doesn't really matter where it's at. It's about 5 inches. So it's within a couple of percent one way or another. Then I'm going to set my dial. I can rotate this face to zero it out. And then, don't know if this will come out okay or not, but I'll start to turn this, and we should see tension increasing. Are we? Yeah, we are. So you're going to see that tension slowly eking up as I tension this blade. And in the interest of time, you'll have to trust me that would go up quite high. And that's the basic idea. So we can figure out for the bandsaws at Sector how much tension is appropriate, and then apply it with that in place to get things set well. Any questions?
Nope. I have a question. So if you're dealing in 10,000ths of an inch measurements, how much time do you have to spend with tolerances of your machine part to get it to, tight enough to hold that tolerance?
Yeah, very little, as it turns out, because all that really matters is So this pivots, and you can see that, you know, that's many, many rotations of that dial indicator. All that really matters, and the key is that this, when it's on the blade, it's pre-tensioned. And so it's really just the pivot point. It's between this dial indicator, the pivot point, and clamped on the blade, and there's no pressure on that. So even though I put a bearing here, it really is actually, there's no real precision machining needed to be able to get to those tolerances as it works out. It's just one, it's literally one pivot point that needs to matter.
Yeah, okay.
Could you have used a less accurate dial indicator if you change that ratio of the fulcrum?
You could, and I thought about that. You know, I wanted to get about a sweep, you know, ideally it'd be about a sweep's worth for, you know, what you'd normally set. I'm happy with half a sweep's worth. And so I would have had to go out like 5-to-1 or 10-to-1 on this. I think what's the question is like this, the ratio of this length to this length is 1-to-1 on mine. But if I would have made this a lot longer, then a little movement here, a little movement down here is a lot of movement up here. So yeah, that I could have easily done that. That would have made the device a little less compact. But the 10,000th indicators are readily available too. So.
Did you turn the locking nuts?
Couldn't quite make out that question.
Did you
Sorry.
make your the little thumb turn on the blade?
I'm still not getting the question.
The technical to lock the blade.
They're all brass nuts. The brass.
Oh, these, no, to my
Oh.
great shame, I bought them on eBay. Yeah,
You make good
I
ladies?
was going to. They aren't quite the diameter I wanted. They're a little smaller. I was sorely tempted, especially as now that I've just been doing some CNC lathe projects as well, and it would be a great project for that. But no, they are bought off eBay.
I have a question. You said you replaced the scale on the dial indicator. Was that just a matter of buying a different card or?
Oh
what?
no, all I did was I didn't replace it. I just taped over the middle of it with a piece of paper that I had made.
Oh, okay.
So that the existing scale is still there. I was thinking about taking it off, but then the handles have to come off of the thing, and then it's like, you know, so it's just literally, this is just literally a piece of Scotch taped paper. I did a design in Inkscape of the right scale and then taped it on there.
Does the scale need to change depending on the thickness of the blade?
It actually doesn't, which is the interesting thing. Since the tension is in PSI and the modulus is in PSI, this actually works regardless of blade cross section, which is one of the benefits of it.
Cover plastic and laser engrave it when you don't want to.
Plastic. Do you
I've
want to know if the cover is plastic? You can laser engrave your scale on it. You can actually, you can lift those handles. They aren't too bad to pull the face off and to put it back on. It's not a big deal.
Yeah, I kind of wanted to make, if I need a 10,000th dial indicator, that I can just, the back, it's just screwed in with 2 of the 4 screws. So it doesn't even come apart because I only use 2 of the screws. So I can unscrew it and then re-screw it back together and use it. And I kind of wanted to preserve that, you know, since the nice thing is, you know, you figure it out, you can figure out the tension you want with this, and then there are other ways to get a repeatable blade tension. So it's not a tool you'd necessarily use even every time you were switching blades, although if you have it, I guess why not?
Any other questions?
I'd be curious if you could, like you said, you could probably just count the number of times you turn the tensioner on the axle. And once you figured out your ratio, I'd be curious how repeatable that is. In theory.
Yeah, it depends. This saw, it depends on like the holes in the end of the blade, you know? So I guess once it started it, but you're right. Once it started to snug up, you could count the rotations and probably you'd be fine. Similar, most bandsaws have a spring-based tensioning system. So you could put some marks on the spring. As long as it was the same cross-sectional blade area as what you tensioned prior, you could do something like that. Like the Tormach bandsaws have a hydraulic, I believe it's a hydraulic gauge with a pressure indicator on it. And that's pre-calibrated for a specific blade cross-sectional area.
Any other questions? All right, thank you, Scott.
Oh, thank you.
Who's going next? Bob, you want to go? Well, I think we got everybody remote unless Caroline's here.
Yeah, I'll go. So my project is my bed. It is right there. It's a Murphy bed, which is why it doesn't look quite like a bed at the moment. But the idea here is I want my room to be like a space themed, but without any particular branding. So sort of Star Trek, sort of Star Wars, sort of whatever, yeah, Battlestar Galactica, just space themed. So I've been doing various projects over the last couple of years since I moved in here to make it like that. So I put in the strip lighting around the top. My door is a sliding door that I can control with voice, or on the outside of the door, there's a tablet PC that has a keypad that I can put a password in and it'll open the door. There's Alexa control over everything in here. So the bed is just the latest project, and I actually bought the 4 sheets of 1/2-inch plywood a couple of years ago when I was first renovating this room, and they've been at Sector ever since. So Chris was happy that this project finally happened over this holiday break because it freed up some space. So I'll start by sharing. Let's see, share this. Okay, so I rendered all of this in SolidWorks, and the plan was to use 1/2-inch sanded plywood, yeah. So there's basically 2 halves. There's the sled half, which is the frame part, and then there's the bed half, which is the part that holds the mattress. And so this is what it looks like when down. The sled part has it's 4 1/2-inch thick pieces, so it ends up being 2 inches wide for all of those sections. And SolidWorks says that it should weigh 175 pounds, not including the mattress. And it is pretty darn heavy to lift. Danielle can't lift it, but I can, so I win. Yeah, so this is all of the parts that I used. The bed, it's a queen size mattress, and so it's 60 inches wide. And I spaced the bed part of it so that the seam was covered by the sled part. So it ended up being pretty smooth. And so, yeah, there's a whole bunch of pieces that make up the bed part and then the sled part. So I, with Chris's help, I used the CNC panel router and milled out all of the parts. It went really quick. I think it took me a total of 3 hours of work, and I was done with all of my cuts. That machine is awesome. And it's using the same software that I was used to with the PCB engraver. So it was really similar process. So after I had the parts cut, I glued and screwed 3 of the 4 part pieces of the sled together, because I needed to keep the 4th one off so that I could put the acrylic in and the electronics. So yeah, that's gluing then and screwing 3 of the 4. And I glued and screwed the bed as well, and clamped it while the glue dried. It was a pretty straightforward process. Yeah, just regular wood glue and 1 1/4 inch wood screws. countersunk so that I could cover them with something to hide the screws. And then I started the priming process. So this photo is in the garage because it turns out the oil-based primer smells and quickly made the house unlivable. So I had to move everything into the garage, but it's winter, so I also had to put the space heaters in the garage, and I had to use a wire extension cord from the house into the garage because 2 space heaters would blow 1 fuse. So I needed to distribute the space heaters. But yeah, it took a couple days to prime all of the parts. And then I started the sanding process, and that took a long time too, and ended up making a lot of dust. It turned my brown boots to white boots. It was a mess. But it was super smooth. I used 220 grit over everything, so it was awesome. And then I brought everything back inside and started painting with some white alkyd paint, which is supposed to be more durable than latex. And it's a water-based, but it's like a hybrid oil water. I'm not sure exactly how it works, but it smelled much better, but it was also a nicer paint. And it's for cabinets and doors and trim. So it's okay. Like, it's not gonna have any issues with rubbing against stuff. So then I started painting everything. It took a few coats to get it as perfectly white as I wanted. And then I experimented with various acrylics. So fortunately, there was a whole bunch of leftovers at Sector, so I played around with a few. I tried taking clear acrylic and sanding the sides so that it would become frosted, and that didn't really work very well. And I tried clear acrylic and spray painting the backside white, and that didn't work at all. But I found this translucent white acrylic, and that worked great. So I ordered a sheet of it from Midland Plastics, and they had it within a couple days. And they even cut it into 2 by 8, like 2 foot by 8 foot sheets, so that I could put it in my car. And then I just cut it on the laser at Sector. I just had to take the wood routing and do an inset by 1/4 inch, and that was it. So then I put those sheets of acrylic inside of the pockets for the, and shimmed them up so that they were spaced correctly, and used wood screws to attach them to the wood. And this is the first, like, making sure everything fits together and looks good. So this metal thing in the center is a piece of artwork that my sister made. She used to be an art student in college, and this was her first welding piece, and she gave it to me. And I really like it because it sort of looks like a rocket ship taking off, but it also looks like this, there's a really fancy hotel in Dubai that it looks a lot like. There's a, yeah, I don't remember the name of this hotel, but if you see it, it looks exactly like it. So anyway, I wanted to showcase that piece of art, and I actually designed the frame of the bed so that it would be slightly deeper than the width of that piece of art, so that I can still fold the Murphy bed down and it doesn't, like, the piece of art doesn't hit the floor. So then I started wiring everything. I was able to put some holes into, I don't know if you can see my mouse, but the small parts between the pockets, I put some holes in there so that I could route one continuous strip of lights that went all the way up and then snaked around so that that one continuous strip lit up all 4 pockets. And then I routed some wires to the other side and did another continuous strip. And then on a separate Wi-Fi controller, I have the 2 middle sections. So the middles are separately controlled from the sides. And then, and then the other thing that I had to do was the adhesive on the back of those strips is not very good. So I used staples to hold them in place in the wood. And this was very time consuming because the stapler was too wide to fit into that pocket. And so I had to individually place each staple and then hammer it in, and then use another metal tool to tap it in the rest of the way. And if you nick that the metal on the strip, then it will cause a short to the other side. And so there were like 3 places where I had to replace small sections of the strip, which was super annoying. But otherwise, it just kind of came together over the course of a couple days. So this is what it started to look like. I had not attached that 4th side. At this point, I was just like placed and kind of held in place. But this was making sure that it all worked and that it all looked good. And it looks like it's floating from above. So then this is another picture of, I realized that the middle ones, I needed to paint the inside because on the side ones, there's acrylic on both sides. And so it looks white, but on the middles, without the white painted on the inside, then you can see partially through that translucent acrylic to the brown of the wood. And I didn't like that. So I painted it white. And then I also put a small piece of plastic in the center because I didn't want the weight of anything on the acrylic to break it. So this is just a spacer to do some support. And then this is what the other side, that 4th piece of plywood looks like. So the acrylic is all screwed in. And then this is right before I assembled the sides. So I used a vacuum cleaner and some dryer sheets to do some anti-static treatment, and just vacuumed the heck out of this thing so that these pockets will not have any dust on the inside of them ever. Because rubbing on the carpet and being a bed, there's going to be lots of dust and hairs and stuff, and I just did not want those to be on the inside where I didn't have access to them. So then I did a little bit of work on the electronics. I got 2 Wi-Fi LED controllers. They're $10 each, so it's a pretty good deal. And I wanted to make it look clean, so I took them out of their enclosure, and then I wired 2 of them together with the same power supply. So one power supply is providing power to both. And then, yeah, so I used a single 12-volt 5-amp power supply. It turns out that when I have all of the lights on full brightness, white, then after a few minutes, it taxes that power supply a little bit too much. But any other condition, it's totally fine. So here you can see I've mounted that. I had a small plastic enclosure that perfectly fit those 2 controllers. And so that's mounted over in a small corner that you can't really see and that isn't impacted when you put the bed either up or down. And so after the electronics were in place, I was able to screw and glue. No, I didn't glue. I just screwed that fourth side to all of the sled part. And I did it with the lights on just to make sure that it continued to work while everything was all the paint was drying. So then there were a couple of finishing touches. One thing I noticed pretty immediately was that when it was up, the mattress had a tendency to fall out. And so I screwed in a strap. I had a whole bunch of strap material left over from Wacky Dancers. And so this is just that. And I put it underneath the fitted sheet. So you can't even tell that there is a strap there holding the mattress from falling out. And then I also put a couple of holes in this art piece and attached it to the bed. So now when the bed it goes up and down, that art piece just goes up and down with it, and it doesn't move at all. And that's the project. The lights are controlled by Alexa, so I can give it commands and it will turn everything on and off. Yeah. Questions?
When are you going to add the actuator so you can tell it to go up and down?
Yeah, so you can see that there is very little clearance up here. Essentially no clearance. And that means that if you were to pivot it about any point where it is now, it wouldn't work. You actually have to pull it out about 2 feet in order to be able to tilt it so that it can go to the down position. So any electronics that or pneumatics or whatever would have to do that, and that's not realistic.
I bet Scott could build something out of Legos for you.
It looks pretty heavy. I don't know. I'm thinking hydraulics.
I should make it play the theme music from 2001 while it lowers.
I think Jansen's got you covered in the hydraulics, so I won't steal his thunder, but he's got some toys here.
Bob, what were the lights and the controller?
Where'd your lights and controller come from?
They're just off Amazon. I can post links in the chat after I'm done presenting. But the lights are just 12-volt RGB strips. So they're not individually controllable. They're you just control the whole strip. And then the controller is there's a bajillion of these too on Amazon. They're only about $10, and it's it is Wi-Fi, but it also uses the IR remotes. So I can actually control all of it from my remote here. So yeah, you can see.
Bob, how did you hide the screws for the side panels?
For the side, oh, I countersunk them and then put in some spackle and painted over them.
Dennis, the one you're thinking of are actually on the inside, screwing outwards. So the ones that you saw on the slides that were going through the acrylic are holding the acrylic to the outside sheet. And then on the outside, he screwed screws back inwards and then spackle over those. So that the ones there, Bob.
Yeah, so
okay.
Yeah, so these the 3 panels here are screwed and glued together. And then this 4th panel is screwed to this the 3, but then I countersunk and covered those holes.
Okay, so you could get in there, but you would have to redo the spackling. Got
right.
It looks really clean. I love it.
Thank you.
Bob, I've had a couple of major disasters drilling and screwing acrylic with wood screws. I'm wondering if you had any special process you did there to make sure you didn't split the acrylic out.
No special process. The first step was having a bit that was the right size with some tape as deep as you want it to go, and make sure you don't push it further than the tape. And And then the second step was using a countersink bit and just going until it started to dig deeper. And then that was it.
All right, thanks.
Don't worry, Bob. Scott gave Jim and I a lesson on ducking and running for cover when accidentally trying to bend acrylic, cold bend acrylic. Scott gave us a piece of polycarb to bend over the pandemic, and we had some fun attempting to bend it.
Only it wasn't polycarb.
I've never seen Jim reach for glasses that weren't on his head so fast.
Yeah, it was funny at the at Midland Plastics because I brought the piece from Sector, the piece of translucent acrylic from Sector, and I'm like, "What is this?" Because I didn't know. And so he's bending it and trying to see if it's acrylic or polycarbonate, and he's like, "Yeah, I can't break this. It must be polycarbonate." And so he goes into the back and starts to look for something that's close. And meanwhile, I'm playing with it and just snap. So he comes back out and I'm like holding up a whole bunch of shards and like, yeah, it's acrylic.
Any other questions for Bob? Awesome. Thank you, Bob.
You're welcome. And thank you for all the help, Chris.
Yeah, no problem. You got to thank Scott too. He's the one who made the panel router run.
Yeah, thank you, Scott.
I have
Love
a
to see that machine get
question.
used to its full potential. So that's awesome to cut that big stuff on it.
Yeah, I love that we've had 3 CNC projects, and it actually reminds me of another question that I had. This old Tony did a nice video on surface mapping, where he could probe a non-flat 2D surface and build up, the geometry of that, and then you could play just a 2D engraving toolpath, and it would warp it to match that. So you could do engraving on non-planar surfaces and things like that. But it looks like he was using Linux CNC for that. Is that the only way to do that, or is anybody familiar with any sort of surface mapping that would work with Fusion or something else?
You could import a surface into Fusion. So what you do is go to your machine, probe your deck or take measurements, and then bring that into Fusion and then make your extrude onto that surface and do a cut and then do a profile on top of that. It could be done, but yeah, typically you take your G code, put it into the controller and let the controller do all the interpolation to correct the mapping. That's what they're doing in Linux CNC, but you can do it the other way where you map your surface, bring in a surface as a mesh or as a surface file and then work with that. It's just harder.
So I have to solve the measuring of the surface side of things first, and then it sounds like Fusion will help with the rest.
Yeah, and that's usually, people will do a contact probe on an input pin. So you'll just run down like a multimeter to tone almost, but that tone triggers the machine to stop and then measure that as a data point. That's what you're doing in Linux CNC too. So,
Thanks.
all right.
Oh, I forgot one more thing. The total cost of this thing was roughly $450 in materials.
You bought that wood pre-pandemic though, right?
Yeah,
It's
that wood
back
was
down to
great.
reasonable prices.
That wood has been, it's now vintage. I'd say it's vintage and aged. It's aged in the Sector wood shop. All right, Davey's gonna present from here. I think we're good. You'll just have to share the screen and get the right one. Oh. I got it.
So you're gonna share the whole screen here?
Yep.
Okay.
Whatever you bring up, gonna get shared. All right, everybody see our screen?
Okay.
Yep.
Oh, except for we can't see the screen. That's awesome.
Oh, well, here, let's do this.
Yeah, it's
All right.
there. Yeah, there we go.
Here.
Never mind, we got a strategy.
This. Also.
So we can throw that over there, but we can share that.
No, I know, I was gonna do that.
All right, now we're good.
So everybody that knows me reasonably well knows that I'm a cheap bastard. And this story starts with the cheapest I think I've ever been. Now, granted, I've dug in a lot of dumpsters and I've haggled a lot of people over a lot of stuff. I bought a used version of this on Craigslist like 7 years ago. And the best part was it was a $5 popcorn maker. And I showed up with a crying baby, 3 $1 bills, and 8 quarters to a random stranger's house and bought a popcorn maker. And that was like, it burned into my soul as like the cheapest I've ever been. And I don't know why, but paying in quarters just seems cheap, even though it's still the same dollar amount. Anyway, so when I got my popcorn maker, it did not have that neat little butter thingy on top. So for, we make popcorn relatively frequently. And so every time I make popcorn, I'm like stacking odd dishes and things and plates and whatever on the thing and hoping they don't fall off. And they never have, but I'm always nervous about it. And so I also happen to have a new CNC mill in my garage, and I'm trying to learn, teach myself CNC milling and so forth. So, ergo, a fancy aluminum butter dish to melt my butter in while I'm doing my, making my popcorn. There's no handles yet, so this is almost done. And in true form, it probably will never actually be completed, but I'm going to talk like I'm going to continue on with the project. So I did all of this. I didn't get Fusion involved at all for 2 reasons, mainly because I have no idea what I'm doing and I'm kind of piecemealing this out as I go. And so I'll kind of give you a quick tutorial of, oh, you got Firefox here. So this thing times out every 10 seconds apparently. So I did this all, I've got a Tormach mill, obviously, I work at Tormach, and I use the PathPilot software to do the entire layout. And so my first one is in my coat pocket. I did out of like 3/4 inch plate aluminum. And so it was really shallow and it spilled butter everywhere and it became nuclear hot as soon as you did anything with it. And so what I did was I found this oddball shape of aluminum at work that was round and somebody had spun it and it was like half used in the corner. And so I grabbed it and brought it home. And the interesting part was this project was full of do a thing to do a thing to do the thing that I wanted to do. And so when I showed up at home with a round billet of aluminum, I had to hold that thing. And fortunately, Tormach just moved and Chris, reaped the benefit of a bunch of piles of junk. And while I was at work, while we were moving, I would root through the junk like I always do. And I ended up with a 3-jaw chuck that I wanted to use. And let's see. And so the problem with that 3-jaw chuck is it didn't have a tool or a base plate. So I'm not going to tell you how long any of this took. It's kind of embarrassing. So I had to make a key, I had to make a base plate, and I had to flip the jaws around. I had to do all kinds, like a weird amount of work just to get this thing to work, but now it works and it's in the drawer and I can use it whenever I want. I found this rod is some random piece that I had, and it looks like a hinge pin from a dump truck. I assumed it was crazy hardened, so I milled it as such, and I was so proud of myself that I milled this hardened steel. Well, my little brother's a welder, and he came over, and the other day, and he was like, if there's a ping test you can do with metal to see how hard it is. He bursted my bubble. It's crazy mild steel. It's not that, it's like tinfoil. And so anyway, I can apparently mill mild steel quite easily. I can also do more stuff, but I haven't gotten into that with my own, kind of process. So anyway, so this project was full of like do a thing, to do it wrong, to do it again, and try it again. This was all done in one go. Like I started with one billet of metal and I got one product out of it. And at one point in time when I was doing I was trying to do some pretty serious material removal, I actually dislodged this in the 3-jaw by about 50,000ths of an inch, and I didn't know it, and I continued to work it. And I actually milled a cattywampus cylinder out of, because it was still held relatively firmly, but crooked. And so I did a bunch of work on it, and I was trying to cut chamfers, and I couldn't figure out why nothing was working right. And then that's when my little brother was there. He actually pointed out that we had to start all over and loosened up. And so the thing got progressively smaller as I went, and so I figured out that I was about 16 thou off when it was crooked, the cylinder walls or whatever. So I was able to recover it all. And then anyway, so I kind of bastarded my way through this thing, 15 minutes at a time or 2 hours at a time. And it's one of those deals where I go out to the shop and I'm like, oh, I'm just going to spend 20 minutes on this. And like 4 hours later, my wife's mad at me and I'm like off in the garage somewhere. And so, that was kind of the bulk of the project. And just to give you an idea, I brought up the PathPilot thing to show you kind of been true, you know, I've done a little bit of fucking every time. I don't even know why. So I did this, I've compiled this all now into one operation, or well, the three operations that I did, but this is not nearly how easy it was when I did it. And I could show you here. And so this is the fun part. Let's see if I can make these file names. So in true, gosh, how do you do this now? This is my favorite part of this whole project. So in true programmer form, copy A, copy 2, final, this is, and so each time I'm making like just tiny little incremental changes to this code as I'm kind of making my pockets bigger and bigger, or smaller and smaller, I guess, it's kind of depending on which way you look at it. And so anyway, so I ended up with kind of 3 major operations. Once I had it chucked in here, you can, if you look close enough, you can kind of see the ridge. This was, I started upside down. And so I did, you know, this pocket, and I did some chamfer, and I did the circle, you know, there's a couple facing operations because the billet was actually quite tall, 4 or 5 inches tall. I guess I'll show you guys. Yeah, so it was about this tall. And so there's some facing operations and some material removal that I did not include in here. But it was a really fun project nonetheless. And I would like to point out that my ultimate goal was an 80 thousandths thick bottom. Because my wife is a mechanical engineer, took a weird amount of thermodynamics classes, and we had quite a discussion about what the properties of this needed to be. And ultimately, the bottom needed to be very thin so that the heat would radiate through immediately. And then this outside diameter is actually, I kept it thick so I could drill and tap a few holes in it. And my plan is to add like a cherry wood kind of handle, you know, a couple little thumb pads for it so I can pick it up when it's hot. Right now I have enough mass that 2 hoppers full of popcorn, which is what we eat, and this thing full of butter means that this isn't yet hot enough and I can still dump it by hand. So I don't know how far I'll get with the rest of the project, but it's a neat theory. Yeah, and so yeah, so this is, yeah, like Chris is pointing out, this is kind of the final, like what the tool paths all look like. But in any one of these things, so this is op 1. And the way I did this is I think very linearly in this so far. I haven't gotten quite to the fusion where you just kind of, you know, create this whole thing all together. And so pocket 1 would have been the first interior pocket here. And because I shifted this and recut it and changed it so many times, I'm actually pretty excited about the final measurement, but I'll get to that. And so this is what, you know, kind of how you set it up here to start with. And so I tell it that I want a pocket so diameter, you know, the depth of cut, and then you kind of give it all these parameters. And then this pocket is set on a 0, 0. You know, I just probed and found a 0 point. And then, you know, and there's a bunch of options. So, you know, there's a pocket and then a profile. And so I would have to do multiple, you know, the pocket goes in here. This shoulder would be a profile. This exterior would be a profile. And then the chamfer, you do a profile without, you know, a bunch of material. And just to give you an idea of what I'm talking about, just real quick. This is a profile where I put in how big the stock was. And I couldn't tell it that I have round stock. You can only tell it I have square stock. And so it starts with all this kind of material here that was so wide. And then it creates the profile in the middle of that that's so diameter. Now, the fun part was, because this was cattywampus, when I straightened it back out, I didn't want to watch it cut air to clear all this out. And so a bunch of those copies of copies and finals of finals and all the various files in here were where I would do this. And I'm actually gonna, I didn't set myself up to show you this part. Let's see, actually here. I do want to show this because I think it's a really cool kind of feature of this software. So let's copy this over and just run this one program. So what I ended up doing, kind of a decent amount of, it's probably out of wonky. Yeah, I'm out of lazy. Yeah. Cancel this. So I got this file loaded. And so I didn't want to watch it cut all this air because ultimately I was only cutting like 3 or 4 ball hairs of metal off the outside of this, you know, on those kind of the finishing, the passes after the first material removal. And so the cool part is you can actually click, I figured out over here, there's a straight line that leads into, I can't click on it here with the space mouse, but the straight line that leads into this arc. And so I was actually able to go up here on this finish pass, start right before it, and then I could start my program here and then hit go. And then, well, I think I clicked on the wrong line here, but I would click go and then it would come from over here and do one round around it and be done instead of watching it all day long, cutting a bunch of nonsense. So that was kind of a cool thing that I became very familiar. You know, I knew that was an option, but I became very familiar with it over this project. So ultimately, that's kind of the bulk of it. I spent like a weird amount of time futzing with the programming. And if I had, and part of my problem was I couldn't quite conceptualize this on all I knew was this diameter needed to be 3/8 inch and this thickness needed to be 80 thousandths. And the rest of it was kind of built around however I got to it, which is part of the reason I didn't start with Fusion and work backwards. And then just to give you the final, so, and then the cool part was I learned a lot on this project. So it seems so simple. And like anybody that's machined anything is probably like, what, you know, who's this guy? What is he doing? But the reality is I learned a weird amount on this project. And one of them was how to use different tools in a different way. And so, for example, I wanted to know how thick this floor was, you know, when it was all said and done, just to kind of check my math. Because like I said, I started with the 80 thousandths from the shoulder this way, but then because I got all cattywampus and I had a diagonal slope here, and then the bottom floor I measured off of here and I had to go down here. And so I had to then re-zero this floor height to this shoulder height to get my 80 thousandths thickness based on this dimension. And it was a lot of probing and checking and futzing with it. And so what I ended up doing was, after kind of dinking around with calipers and trying to figure out what I was doing, where's my, I came up with this method, which I'm kind of proud of. And so this is their normal height gauge. And I actually bought a set of, no, I have 1, 2, 3 blocks already, the gauge blocks. I actually bought a set of gauge blocks for this because I kind of got pretty close. And so, oh wait, here we go. And so I took the granite block here. Do you guys see the mouse? Oh, there it is. So I took the granite block, put a 1/2 inch gauge block down, zero the caliper here, put it inside, and then let's see. I think if I do this, oh, let's see. And then I set the 1, 2, 3 block down, and I'm at 79.5. Which I consider pretty good for having basically no idea what I was doing most of the time. And so anyway, so that was, you know, ultimately it works. It fits very nicely in the popcorn maker.
5 10,000 on popcorn makers, just I'm not sure if it's gonna be
So here it is in action. Anyway, so that was like my really weirdly long-winded solution to how to melt butter in the thing. And I only have to let the popcorn maker run for about 20 extra seconds after the popcorn pops to get the butter melted. So, because I was curious if I was going to end up like, you know, leaving the popcorn maker on for an extra 5 minutes just to get my desired effect. But they actually, you know, Orville Redenbacher knew what they were doing when they designed this. So, and maybe if I had shitty Chinese plastic, it probably would have conducted heat better or worse, or I don't know.
I was gonna say, I did keep mine and it stopped.
Well, in about 3 days, I maybe can get you another one.
3 to 5.
Yeah, right.
What about the lid? If you don't get your 20 seconds.
What'd you say?
Put it, make a lid that fits on that.
To go over this?
Nice.
Oh, all right.
Maybe it's UVC though. Reflect the heat back.
Oh, okay.
Awesome.
I hate to break it to you, but you know they make pressurized like movie theater water spray cans, right?
Yeah, no, that's chemical spray. I want butter on my popcorn.
Oh, but that's the beauty of it. That's the best game changer ever. I discovered that.
Yes. Okay.
Nozzle, spray, spritz.
Any other questions? Okay.
How long would it take to actually do it?
It's really hard to say because I did it in such a piecemeal, and I'd like mill a thing and then I'd do a bunch of math and try to figure out like what is 4/1000ths of an inch subtracted from this with the outside radius of that. And it was kind of a lot of strange math to get there. Aaron.
So is there any difference between Craigslist popcorn and regular popcorn?
regular popcorn costs real money and I paid in half fake money.
Hey, laundry money, man.
Yeah, laundry money.
Jesse, you wanna go? So I'm gonna highlight my phone and then I think I can use my phone as a remote video
I
camera
got this
here.
camera going.
Oh my God, Brian's got the camera going?
Only took an hour.
Nice, all right, sweet, I'll highlight that one. So we wanna get the, who's over there? Aaron, you wanna hit the left light switch, turn the light on?
What's that?
Can you hit the left light switch, turn the light on? Left light switch, turn it on. No, turn it on. Turn the other one on. There you go.
This thing?
Yep, yep.
Okay.
Oh yeah, that's right, slides. Hang on, we're getting there. So I think sharing the screen will take over the other one. But we'll find out in a second.
Yeah, right. Yeah.
All right, I think. Good.
Yeah, right. And, nutrition.
All right.
Oh, yeah, yeast popcorn.
Yeah.
Plastic.
And so,
Actually, popcorn's helping nursing up on top of it.
yeah.
So for the last, I guess, 4.5 years, I've been doing various hydraulic projects through college, kind of as a side project as in addition to the other stuff. So basically watched too many Boston Dynamics videos and thought, those don't look all that complicated. Looked through a lot of patents and started making hydraulic stuff. So this is how far I've made it in designing stuff off and on for the last 4.5 years. Most of the work was ended up being done this semester because I had kind of a light last course load. So got this pump on eBay for $15. It's a really tiny gear pump that was originally designed for use in automatic transmission, so automotive parts, so it was a lot cheaper than typical hydraulic components. It's kind of small, which we'll come back to later. Used a via ESC in torque control mode as the motor controller. So that's just, I guess I think the software is open source, hardware might not be, but a motor controller where you can adapt a bunch of settings for running a brushless motor. The important part is that it has a torque control mode, so you can have the throttle input be proportional to torque, and through the gear pump you get like a relatively constant pressure output. I'm trying to replicate the very expensive variable displacement pumps they use that have piston servo mechanisms to keep the pressure constant, but able to do that with much cheaper components in a smaller scale. So here's the initial prototype that I did for hydraulic stuff. Borrowed a motor and motor controller from one of my electrical engineering friends. Machined a rotary valve that's kind of sitting in the fan there. The pump's also at the bottom there. I was able to just take the vice grips and rotate the valve back and forth to make the cylinder move. Also test the cylinders, because I got these at a surplus store in the Twin Cities, $10 a piece, in a box labeled arms ? So I wasn't exactly sure whether they were cylinders or not, but they've got a decent hydraulics program up there, so I think it's like scrap that some poor grad student had to weld together and then they threw them out when they were done with the project or something, but I got them very cheaply. Here's kind of the belt design. Let's see if I can get them out. Wow. So there's pretty much how the valve works. There's pressure in on the left there, and when the valve is rotated, pressure goes out the top port, and then from the other port on the cylinder, that's the bottom, starting from the bottom and then going off to the right. So you can have the rotary thing pointed in that direction, moves the cylinder one way, rotate it 90 degrees, goes the other way. Have it locked in the center position, no fluid goes anywhere. So closed center valves, that's why the constant pressure system is important. I worked through a lot of other valve designs, and this was basically the only one that was practical to machine. And from the early prototype, I had a pretty good idea that main improvement off of the previous valves is adding areas in the top and bottom. So that side gets pressurized, and then there's little filed notches that go up to the top and bottom there. So equal area from that part and those two parts, so that when this side gets pressurized, it's not just jamming the spool over to the other side of the valve. This is kind of what the entire valve layout looks like. The pump's attached on the bottom, fluid goes up and then goes to both the valves, and then exhausts out that side and that side. And then these 4 things go up to the cylinder connections, and then drive shafts go up to the top there. So made some valves. I kind of went towards the like machining valves from scratch design, so I could make them smaller, and was kind of cocky about whether or not I could hold the tolerances that were necessary to make this work properly. So probably hold a couple hundred psi, not the several thousand you typically get with commercial valves. Here's kind of the internals of the system. The pump and valves are all submerged because I didn't want to do shaft seals, so I just dunked them all underneath the fluid and didn't really care about what's leaking out where. There's a drive shaft going down from the top. It's connected to the motor. That goes down to the pump that's there. Valves are there, and then the drive shaft for those go back up to the servos on the top. So a couple drive shafts, and then a bunch of copper pipes. The 1/4-inch copper pipe can actually hold a couple hundred psi. If you stick it inside a metal container where you're not too concerned about adversity, you get kind of close to the limits. So I've got 2 proportional directional valves. Here's a pressure relief valve that I made. I'm not super certain how well it works. It's set at about 100 psi because that's what the air source I was using to test it went up to, but it'll go up to just being not a valve at all if I crank the bolt down all the way. Haven't set up the pressure transducer yet, so I don't really know what pressure I am throwing yet. Less than 100, I think, based on that valve setting. Here's the top section. There's 2 aluminum blocks that have 1/4-inch NPT connections for the hoses, and then 2 hobby servos to move the valves, and motor shaft connection, and then just 4 spacers to go up the top section of it. Top section, the pressure transducer is just stuck into one of the hose blocks there, and that has another copper section that goes down to the pressure relief valve. So pressure transducer, I think also an automotive component up to 1000 psi. Should just be an analog thing that I plug into the Arduino there. For all the connections of this, a lot of them are these little O-rings, so I just countersink an O-ring in there and got the tolerances well enough so it worked. And these other connections are kind of a disaster that I figured out worked in the first prototype and just kept going with. So the procedure for that is you take a chunk of steel, you drill out a hole that's a little bit larger than the 1/4-inch, and then you braze into that hole, and you drill out the braze, and then sweat solder into the braze connection there. I wouldn't recommend it. It has worked so far. It was really a pain to get all of the connections on this one though. So like the initial prototype had just like 4 connections. This one had a bunch more and complex stuff and a bunch of things bolted together. Turns out once I solder that thing in, you can hardly access the bolts on the backside there. And you have to fiddle around them now and then. It's kind of bad. Here's the reservoir, 1/8-inch aluminum. You can see a little bit rusty on the aluminum welding scales initially there. So this took way longer than I was expecting. It also doesn't help keeping things the proper temperature when you're dunking it full of water every couple minutes. So eventually figure out how to stop dunking the electrode into the puddle and grinding off the aluminum from that every time. But after numerous tests, I eventually got to hold water at least the bottom, like everything up for the top couple inches. And gave up on the shaft seals on the top, so if it tips over, it's going to leak anyways. So I just held it close enough and got on with the rest of it. Control side of things, I've got an Arduino and some potentiometers. So Arduino has like a voltage divider thing with the potentiometers to get analog values for servo positions. That basically I've got one potentiometer for PWM output for the vest, and then one for each of the servos. I have kind of a silly power supply set up where I have a plain speed controller powering the servos and then the output of the VSE powering the Arduino. I tried initially powering it all off the desk for the plain ESC, I don't remember exactly which one. But every time the servos would move, there'd be voltage drop on the power supply that was powering the potentiometers. So like it'd move and then it caused the power supply to drop and then it'd move again. the servos were just kind of vibrating a lot. So decided rather than doing things the proper way, just add another power supply and add another battery and deal with having 3 batteries on it. So I wasn't super concerned about having this be a clean setup for now because this is just getting everything working. So later on, I'm going to try and come up with a better solution for the electronic stuff. Initial testing, I got both cylinders to move. Turns out a 1 liter per minute hydraulic pump designed for occasionally shifting gears on an automatic transmission doesn't really have a lot of flow. It's about 1 liter per minute. So it moves stuff. It should be able to do high enough pressures, but looking into getting a better pump if we're going to use this a lot. Major takeaways from this: building hydraulic components from scratch is impractical, and compared to purchasing used parts, it's an interesting design machining project. Not something I'd really recommend to anyone that has like money rather than infinite access to machine shop in college. The brazing and drilling and soldering things, it does technically work and it fits in small places, but if I ever have to do maintenance on it, I'm gonna have to use either like figure out how to get all the oil out of it or just put a blowtorch on something that's full of oil, which is not a great strategy. Pump is kind of small, so ongoing development of this, gonna connect the pressure transducer. Gonna try and add some claws to this to get the full exoskeleton type stuff going. Improve the ergonomics of the backpack. It's pretty hard to get off. It's pretty hard to take off and put on currently. And rather than having a throttle control, I'm gonna try and have like trigger controls for each of the valve servos. And so it'll just like add together like how fast it wants each one to go in each direction. So instead of having another control, it'll just be either the triggers or the cylinders. If stuff's working, I'm going to try and get down with this going with the camera on the floor.
Yeah, I'll kill the screen share. Let's see. So I think I've got the other camera, yep, pinned. First hand throw hydraulic fluid all over the place. It's actually super clever to just put the whole valve assembly in the reservoir and then you don't have to worry about.
I think the pump might have technically had some sort of shaft seal on it, but it's designed to be submerged anyways. Easier to do that way. There are a lot of similar designs for valves that have actual shaft seals on them, but I was trying to have like a faster response rate on some of the stuff, so less drag is important. And with the torque thing for the motor, like if there's too much resistance there, it'll get screwed up with trying to maintain the pressure accurately. So move that around. With the assembly moving back and forth. How much force do you think that's putting out? No idea.
100 psi times about an inch, so probably 100 pounds.
Yeah, somewhere around there.
I like that it was no costs held for the quick disconnects on the cylinders, but every effort to avoid buying fittings.
Yeah. I mean, they're not expensive quick disconnects. Those are the cheapest I could find.
Yep.
It's just I couldn't figure out a way to assemble the cheap hoses together without having some sort of rotary gears in there. I got the hoses where you have like you just have the thread NPD things on them rather than the actual thing there. So between the solid blocks, I had to have some part that would rotate.
Anybody got any questions?
So if you have your pump system in a reservoir full of fluid, how do you, and then you also have a pump that's under spec, how do you know you don't just have an inefficiency with like a leak somewhere that's just dumping into the reservoir instead of pumping out?
Well, the specs for the pump are about 1 liter per minute. That's pretty low.
Okay.
So it could also be doing problems on the inside there. There's no filter on it, which is a bit of an issue. I don't really know whether or not the pressure relief valve works. Just like the cross-sectional area of the output doesn't line up with what it could be because of the way that it's made. And I haven't really tested it beyond air because I didn't want to have it spraying oil all over the place. once I get the pressure transducer hooked up, I'll have better ideas of what pressures are happening. And I can kind of see what's going on with the valve, so I can just like bottom out one of the cylinders and continue to pump. I have some idea. There's some like I have like a ring fit between the like the spools and moon valve body. So there's probably a bunch of oil leaking out of there also. Kind of a lot of problems with it, but it does move the cylinders. Cool. My original plan was something that had about 14 degrees of freedom, so I was really looking into making custom valves. Because even at like, if I was just going to do this, I'd get like $200 or $300 like valves to use in aircraft, because they have eBay things that are super old that are pretty good. And then probably like a larger pump to describe those properly. Instead of like move the jaws and you start clothing with my clothes. I was looking at how much that would cost for 14 degrees of freedom and decided to figure out how to paint those. And the initial prototyping worked, and that was, I mean, kind of surprising. So that was literally a bolt that I just turned down the machine some flax into it and stuck into that. Like a pan that I went to Walmart to get to barely have the fluid. Other questions?
Anybody online got questions?
It seems like really just an exercise. Is there practical?
I want to do like dual wielding, light type stuff, like rip something apart. That's about it. That's kind of the goal of that. I found out like partway through this project, they actually make wireless jaws of light now, which just have a really nice lithium battery on them. Previously, they had the hose thing where you had to pump. The technology's improved for that. I have dual wielding on them. That's about it. Not gonna have enough horsepower.
They did the conversion real quick, our Bobcat, so that's 33 horsepower, and that's got a 50 liter per minute pump. So a Bobcat's output, right, is 50 times more than what you've got. Just for order magnitude, I was just trying to figure out like how is a Bobcat 1,000,000 liters a minute? Is it 100 liters a minute? Is it 10 liters a minute? Where does it land? So anyway, it was just interesting to see. So but obviously it's got a lot more pressure behind it. So
yeah. The pump is supposedly good up to about 1,000 psi. Not sure I trust that. Given that it was the $15 thing that was like advertised as radio control components, it might have been a reject from the automotive world. So, I don't know. Basically, I put all the sketchy stuff at the reservoir and tried to use like actual hoses and fitting. That's the reasonability of the outside parts.
that's awesome.
Looked up hydraulic injection injuries early on in this process. Got pretty scared, made air valves for a while. Eventually came back to this.
Cool. Thanks for presenting. I think Carolyn's got one other presentation. Still around. Maybe. Oh, there she is.
We could wait for another month if you want.
It's up to everybody. I don't care. I think go for it if you want to. It's up to you.
All right, I'll make it fast. Looking for the share screen, but there we go. All right, can you see my screen? Yep, okay. Hi, my name is Caroline. I'm a cartographer, so I make maps professionally for work, and then I go home and work on personal projects, and they're usually maps as well. And in this case, I worked on a little Christmas ornament that was the shape of a lake. So if you are familiar with my past projects at Sector, I've done several projects where it's a lake using map data, two-dimensional CNC machinery, and these are some of my past projects, and this very much resembles those. Here is the final product. So you can see what the finished piece looks like, and it's a small lake in western Minnesota where my grandmother lives. And I thought it would be a nice little ornament to make for my aunts and uncles and cousins who are familiar with this lake and have spent a lot of time there. And for my grandma who still lives there. So the first designs of this were quite a while ago. I started working on the laser cutter in 2017 and didn't finish it before that Christmas, and I kind of dropped the project, and then Sector moved to a different building, and this is about as far as I got. I had picked up the data from the Minnesota DNR, had the bathymetric data, but this lake is really shallow. I don't think it's actually all that exciting. You can try to make it exciting with lots of with all the lines of the bathymetry that they've got here, but I decided just the overall shape of the lake would be sufficient for this project. And that's about as far as I got. I got as far as cutting a piece in a textured acrylic that looked pretty cool, putting a wooden frame around it, but there were a few things missing to this design. I didn't have a way to hang it. I kind of wanted to turn the lake part blue instead of this clear, and I couldn't at the time find a textured blue acrylic material, and I didn't have a way yet to attach the pieces together. These are two pieces just nested. Even though I could get them to fit pretty tight, they were not actually attached to each other, and I didn't think any kind of glue was going to look good in between. So there were a few years in between, and then I started working on it again for this Christmas. So we started with we actually started with some of the acrylic, and then Chris made the suggestion that I could actually get stained glass because we had access now to a water jet cutter. So I went and bought some stained glass from the Vinery, which is a stained glass studio that has now closed. They closed at the end of December, but I got some pieces of stained glass for like 30% off. And we tried with the water jet cutter. There was a little bit of troubleshooting that had to go on with the water jet cutter. The first two pieces that we cut, we managed to break, and we attributed this to the sand that is the abrasive material in the water jet cutter. It was not falling properly into the feeding mechanism, and we think that it's because it was clumping, it was too humid. We switched out the sand and it worked better. So Chris and Kate were helping troubleshoot on the water jet cutter, but after a little bit of work on there, we got several glass pieces. You can see the acrylic piece at the top in this image on the right, and then the glass pieces. And the laser and also a sander to bring down. So I had a top piece and a bottom piece, and then a piece that wraps around the edge of the glass, and this builds like a sandwich of wood around the glass piece. And the sander brings that center piece down to the thickness of the glass. So sanded, laser cut, and these are all the pieces. I had the parts to build about 6 of these. I ended up assembling 4 of them so far. Some of the wood pieces broke. The wood tends to have some kind of voids or maybe glue or something in it that can sometimes not behave with the laser, doesn't cut with the laser, and then you have to break it or it leaves a hole in it. So this was my first sort of mock-up, just hanging the pieces together to see what it was going to look like, but that's not attached yet. Here's the process of putting everything together. Wood glue on the edges, hot glue between the glass and the thin pieces of wood that extend out over the glass. And this is, I think, 1/64 inch veneer. So really thin, maybe 32nd inch, but very, very thin veneer. So I wanted to stick down to the glass on those peninsulas. And all of the pieces of wood, when you cut them on the laser, results in this soot on the edges. So I did have to wipe those down with a paper towel and just ran that around the edge a lot of times to get rid of all this black soot that's on the edges of the wood. And that's the final product. So that's it. I'm a cartographer, so I'm open for any map questions people have, because I know that maps are a really fun thing to do with the CNC machines at Sector. So that's it.
Any other questions are $5 a piece, but map questions are free. That's what I'm hearing.
I want to know what the water jet, how did you do the cut the glass? You can't just put glass in a water jet, right?
We sandwiched it between some waste material. So we used, in some cases, a piece of wood, and in some cases, a piece of like corrugated plastic, and put that below and above. And those were sacrificial materials that cut out in the same shape as the glass, and then you just toss them out or keep them in a giant pile of extra pieces.
I couldn't help but notice that you didn't cut the peninsula into the glass. Was that something you tried and then gave up on, or you didn't even try?
I assumed that it wouldn't work, and I decided to go with I decided to go with this like sandwich thing before I even got to the idea of using glass. I had done the sandwich structure with a piece of acrylic, because then I knew how to attach everything together without having to fit tightly, the peninsula of the wood into the other pieces. It made more sense to just overlap the pieces. So I was already on that design, and then I didn't even try to put that to cut that sharp little peninsula into the glass.
Other questions, anybody? Did your grandma know what it was when you gave it to her?
Yes.
Thank God.
That's another beautiful piece of art you've made there.
Thank you. Yeah, the stained glass is a really lovely material. I have some left over, and I need to find some other cool ideas for it.
Yeah, Kate immediately honed in on how many complicated, ultra complicated Kate-like projects that she was thinking about making. So she anticipated going to go buy the vinery out of glass. So I don't know if she did that or not, but I'm sure at some point I'll find out when she shows up with a huge stack of glass to cut out. All right, well, it's getting late, so I'll cut us off here, but it's good to see everybody. Stay safe, and I guess I'll see everybody around for the next crazy projects and next month, if anything. Let me know if you got 7% next month. Thanks everybody for bringing cool things this month. It's great. So good night, everybody.
Thank you.